Hello, we are Senior Design Team ME33 and MEM14. This project, sponsored by the Naval Undersea Warfare Center, is hydraulic pressure analysis for bearing degradation detection.
This Naval Undersea Warfare Center, or NUWAC, is one of two Naval Undersea Warfare Centers within the Naval Sea Systems Command. NUWAC Division Newport is the Navy's full spectrum research, development, test, and evaluation, engineering, and fleet support center for submarine warfare systems and general undersea warfare systems. The team is under the mentorship of Raymond Mastery to design a mechanical linkage to determine if a relationship between hydraulic pressure and bearing degradation condition exists. This relationship, if found to exist, will be used to better prepare for submarine dry dock maintenance, saving time and money. Since the external linkage and its bearings upon the submarine cannot be monitored unless visually inspected during dry docking, difficulties will arise that cause maintenance delays and increased cost. However, the hydraulic actuator that operates the external linkage can be monitored inside the submarine. The goal of this project is to determine if there is a way to monitor bearing failure based on the pressure readings of the hydraulic actuator.
Our final design incorporates 3 pivot joints sourced from 8020.net. These joints are individual adjustable to increase the friction between each joint. Initially, the joint number 2 was supposed to be a ball bearing, but it would be harder to find, control, or estimate the friction of a ball bearing. We decided to substitute it with same joints as 1 and 3 for better friction. The short video represents how this is accomplished. The cylinder is a 3000 psi max actuator with a 12-inch stroke. It is driven by a pump motor assembly that results in a max pressure of 1600 psi when the linkage is not under any added friction.
The main variables in our experiment are the pivots of our linkage. There are 3 rotational pivots with adjustable tightnesses and 1 sliding bearing. The input to the system will be our hydraulic actuator producing the linear motion of the sliding bearing, which will in turn move our linkage arm. The output will be the pressure readings, which will be recorded in LabVIEW and analyzed to identify the relationship between various failure modes or the increases in friction on different pivots. The pressure transducers will be using our source. We will be using our source from Transducers Direct and have a maximum pressure reading of 4000 psi. Due to shipping delays, our backup plan will involve collecting data from our gauges that we currently have on there and that are already implemented into the hydraulic system.
This video demonstrated our final linkage assembly as well as how the system moves. It is operated by a switch that can either extend or retract the actuator. Data collection will use this full extension and retraction as one full cycle.
These pictures show the pressure in our hydraulic lines for a full extension and then full retraction of our actuator. When we constrain our linkage and increase the friction between bearings, we see a slight increase in the necessary pressure needed to operate the actuator. This can be seen as an impulse by the gauge. As we introduce our digital transducer, we will expect to see more clear-cut values that can aid us in determining a relationship between bearing failure and pressure traces.
Thank you for watching.